See what we have by Snell's law. I'll explain the derivation. What we have by Snell's law. By Snell's law, we have u1 sine I is equal to u2. That means that eta only. Eta you can make, or you can make mu2 sine r. So you can write it as this marker is not working properly. Seems there is a technical glitch. Just let me check. Yes, it's working now. Yes. So now we have actually there was some technical glitch. So the next one is refraction at a spherical surface. We'll start with the Snell's law. What is your Snell's law? In the Snell's law, we have mu1 sine I is equal to mu2 sine r. Okay. If angle is very small, you can write in place of sine theta, you can write only theta. And we have also studied that your angle of incident will be equal to alpha plus gamma, and your gamma will be equal to alpha plus r. Even if this diagram would be in place in front of you, you could have understand this is the exterior angle property. So this will be equal to what? This will be equal to mu1. In place of I you can write alpha plus gamma is equal to mu2. In place of r, you can write gamma minus alpha. So therefore, mu1 alpha plus mu2 gamma is equal to mu2 gamma minus mu2 alpha. So therefore, you can write alpha common. You can take alpha common, or if you want, you can take alpha common, or else you can write here in place of r, you have written gamma minus beta, not alpha. Just a minute. Yes. What do you have for Snell's law? Snell's law, it's mu1 sine I, mu2 sine r. And if angle is small, you can write sine I as I and sine r as only r. Then what you have studied? You have studied that I is equal to alpha plus gamma, and gamma will be equal to, it's beta plus r, not alpha. It is beta, not alpha. Just a small changes. This will be beta. So this will be beta. Not a big deal. This will be beta. If that is beta, this will also be beta. So this alpha, this will be what? This will be here. What you can write here? You can write mu2 common, means here you can write mu1 out, alpha plus gamma is equal to mu2 gamma minus beta. So therefore, this will be what? Mu1 alpha plus gamma, mu2 gamma minus beta. So here you can write mu1 alpha plus mu2 beta, which will be equal to mu2 minus mu1 gamma. Now, if you check, we know that angle, we know that tan alpha is equal to np upon minus u, and beta will be equal to np upon v, and gamma will be equal to np upon r. We know all these properties from the diagram. So what we can do, we will write the thing which we have derived previously here. So from this equation you will get, from that equation you will get u1 np upon minus u plus mu2 np upon v is equal to u2 minus mu2 minus mu1 into np over r. np will get cancelled, and as light is moving from rarer to denser medium, what you will get minus u1 over u plus u2 over v is equal to u2 minus u1 over r. And if light is moving from denser to rarer medium, you will get minus u2 over u plus u1 over v is equal to u1 minus u2 over r. Okay, so this was the derivation for refraction at a spherical surface. For spherical surface. Now what we have? Now we have for lens. I explained the derivation with the help of this figure. Derivation, reflection by lens. See, this is the diagram. Diagram A. Okay. This is U. From here to here it is U. From here to here it is V. And from there, see, here there will be a formation of image. And this will be V. This is image and this will be V. So if you see two surfaces, for surface 1, for surface 1 you will get minus mu1 over mu plus mu2 over v is equal to mu2 minus mu1 over r. I'll mark it as equation 1. For first surface, first surface means for here, and this will be your second surface. If you see the first surface, this is your first surface. Okay, then what? Then for surface 2, for surface 2 you will write minus of mu2 over v plus mu1 over v is equal to mu1 minus mu2 over r, and this will be what? This will be your equation 2. Now if you see, if you will subtract these two things, what you will get? You will get mu common. Yes, you get mu1 common. If you subtract these two things, you will get mu1 common. And first you can write 1 upon v minus 1 upon u. is equal to, here also, u2 minus u1, in bracket you can write 1 upon r1 minus 1 upon r2. So if you see further, I'm writing it on the next page. I'm writing it on the next page. If you see further, you can write you 1 upon v minus 1 upon u is equal to u2 minus u1 over u1. We are keep putting that u1 here. So that will be what? That will be 1 upon r1 plus 1 upon r2. As object is at infinity, v is at focus point. Yes, image will be formed as image will be formed at infinity. That means object is at focus point. Okay, we have studied that thing. So therefore you can write here, in place of u, you are writing infinity. 1 upon infinity means 0. In place of v, you are writing 1 upon f is equal to u2 minus u1 upon u1, and in bracket you will write 1 upon r1 minus 1 upon r2. Here there is minus sign. This is your lens maker equation. What it is? It is your lens maker equation. This is your lens maker equation. Lens maker formula. Okay, this was your lens maker formula. Now next we have combination of lenses. In that only we will cover the power of lens part. Yes, combination of lenses. See, for the case of for combination of lenses, if two lenses are there and they are in contact with each other, that means they are in touch with each other, then you will write combined focus length as combined focal length as 1 upon f over 1 upon f1 plus 1 upon f2. Okay, this will be the formula. After that, what will be the net power? For net power, you will have power is equal to P1 plus P2. So what will be total magnification? Total magnification will be M is equal to M1, M2, M3. Okay. And what will be the unit of power? What will be the unit of power? Yes, power unit is what? Watt. Nah, this is optical power. So here you will use dioptray. And one dioptray is equal to one dioptray is equal to 1 meter inverse. One dioptray is equal to 1 meter inverse. Okay.